In this video, we're going to create a finite state machine to control an AI. And we're going to do it in Unity, and we're going to use the Mecanim system to do it. And what we want to do is we have this turret in our scene, and the turret is going to want to try and fire at the player. And the player is going to be able to move back and forth behind these walls. And basically, the turret needs to figure out where the player is, turn to face the player, and then fire bullets at the player. And this is an ideal situation for using a finite state machine, because we have a finite number of states, essentially, that our turret can be in. Our turret can be sort of waiting for the player if the player is hiding behind a wall. A turret can be turning to look at the player, targeting the player, essentially. And the turret can be firing at the player. It can be actively attacking. So because this is well done with finite state machines, we're going to try and do this with Mecanim. So the first thing we're going to need is a finite state machine. And we can create that asset, and that's going to be an animator controller. And we'll just go ahead and call that simple FSM. And if we take a look at that in our animator window, we're going to start out by thinking about the states that we need and thinking about the parameters and sort of putting this problem together. So the first thing is that we're going to need some kind of a wait state. When the player is hiding, the turret is going to be waiting for them to appear, and this is going to be our base state. So I'm going to create a state, and I'm just going to call this waiting for player. Next up, I'll move this a little over to the side. Next up, we'll create a state to where we're going to be turning to look at the player. So we'll call this targeting player. And finally, we're going to need an attacking state. And we're going to be needing some transition between these. So we're going to start out waiting, and when the player becomes visible, then we want to start targeting the player. If the player becomes invisible, if they go behind a wall, we want to go back to waiting for them. Now, if we're targeting them, we're going to be turning toward the player, and if we get close enough, so within some number of degrees from facing the player, then we want to start attacking the player. And if the player sort of gets out of that range, then we need to turn to target the player again. So we'll have a transition here. And while we're attacking, if the player becomes invisible, then we want to go back to this waiting for player state. Now, we don't want to go directly from waiting to player to attacking player. We want to go through this targeting phase every time. When the player becomes visible, first we want to check what's the rotation between where we're looking and where the player is. And then if we're already looking in the right direction, we can immediately go on to attacking player. So we don't need to transition the other direction between these two. And we're going to need some parameters. So if we go over to our parameters, we're going to need, it sounds like 2 from what I've been explaining so far. We're going to need something that's a bool value, and it's going to say, essentially, can we see player? And that's going to be a bool. Whoops. Can we see player? And then we're going to need another one that's a float, and that's going to be something like angle to player, and we'll make this in degrees. And we'll just leave a note for ourselves in the name of the variable. So let's set up our transitions between these various states. First of all, we know that we want to transition here when we can see the player. So can we see player is true. And we want to go the other direction when can we see player is false. Between targeting and attacking the player, I want to move to attack the player when our angle to player is less than some amount. And we can tweak this, but for now we'll just say 5 degrees. And then we want to go the other direction when our angle to player is greater than 5 degrees. And from attacking to player back to waiting to player, we're going to transition when we can no longer see the player. Alright, so we have our 3 states. We've got some transitions between them. We're going to turn off this exit time because we want to transition immediately as soon as these various conditions become true. And it looks like our state machine is pretty much set up. So let's go back over to our scene and let's get it set up in this scene. And we have our turret gun, and that's going to be what's going to be rotating to face the player. And we do have a couple scripts, and I'll explain those in just a moment. But we're going to need an animator, and we're going to need to attach our animator controller. Alright, so let's talk a little bit about these control scripts that we have. We have a few things that have to happen in the scene in terms of controls, and I've already gone ahead and set these up. We have one script on our turret, and we have one script on our player. And the player script is pretty darn straightforward. The player script, basically, if I pull this up, it allows us, mostly it's there to allow us to move. So when we press left and right, the player moves behind these various walls. And we are also setting this up as a singleton. And we're setting this up as a singleton so that we can create scripts in our finite state machine and we can get a handle on the player. Our scripts in our finite state machine live in our animator, they don't live in our scene. So we need some way of getting from the animator to a reference in the scene, and that's how we're going to do it in this case. We also have this turret eyes, and the main thing that turret eyes does is every frame it sends out a raycast and it looks for the player. So it sends out a raycast from its current position to the player position, and if it hits something with the tag of player, then it says we can see the player. If not, then it says we can't see the player. So all it does is set a parameter that our finite state machine is then going to use. And we've also set this one up as a singleton so that we can easily access it from our finite state machine. Now, in this particular case, this works just fine because we have one turret and one player. In a case where we had multiple turrets, multiple players, a singleton probably wouldn't be the right way to do it. You'd want to do it some other way, and there's a number of different ways to get between the scripts that we're going to attach to our finite state machine and various objects in our scene. Now, one last thing is I've just added a couple of gizmos, and these gizmos are just going to show us what's going on to make it a little more obvious for us what's happening. And basically, our blue gizmo here is going to be our raycast, so it's going to show us the raycast between the turret and the player, and whether it's intersecting a wall or not. And then the white is just going to show us the forward direction, the current forward direction of the turret. And we're going to be turning so that our forward direction is coincident with this line. We're going to be turning so that we're looking at the player. So that's our scene set up so far. And we've attached our finite state machine that's going to drive our turret. So the next step is we're going to need some scripts in our finite state machine. And what we can do is we can click on one of these states and we can add a behavior. Now, we need to figure out what our behavior should be. So let's start by sort of describing it in plain English. First of all, when we're waiting for the player, what are we doing? Well, we're actually not doing a whole lot. We're just kind of sitting there waiting for our eyes, which is our script attached to our turret gun in the scene, to see the player. So we're actually not going to have any behavior here. We're just going to be sort of turned off. As soon as the player becomes visible, we're going to want a script that's going to turn us to face the player. So I'm going to just go ahead and add a script, and I'll go ahead and call that script target player. I'm going to hit create and add. And we've added this target player script, and now it shows up on our state in the finite state machine. And I'm going to go ahead and do the same thing for our attacking player, and this is where we're going to need to fire our bullets at the player. And so we'll just call this, attack player. Alright, so we've got our two scripts set up. We need to start adding some logic to them. Now, by default, when you create these finite state behaviors, we'll start with target player. Unity gives you a stub of a script, and it actually gives you, here are the base events that you can use all commented out. So awesome, that saves us a step of having to look things up in the script reference. We can just get started programming. And we're going to need some logic here. And since we're going to be wanting to target our player every frame, we'll use this onState update. So go ahead and uncomment this. So what are we going to need to do here? Well, we're going to need to, first of all, get some references to stuff in the scene, and that's why we have those singletons. So first of all, let's grab the turret. So actually this is a transform, because what I want is the position of the turret, and that's going to be the turret eyes instance dot transform. So the instance gets us the reference of the script attached to that game object, and then we get the transform from that script. Next up, I want to get the player's relative position to the turret. And I'm going to save this as a vector 3, and we're just going to call it player pause rel to turret. And we're going to take the turret, and we're going to use something called inverse transform point. And what this does is it transforms a point from world space to local space for this object. You can check it out in the script reference if you're curious to learn a little bit more. And we're going to use the player singleton, so our player.instance.transform, and we're going to grab just the position of that. Alright, so now that we got those, we need to calculate the angle between the player and the turret. So float angle, and to start out, if we start poking through the script reference, we're working with vector3 since we have positions. We'll see this handy function called vector3.angle. And that wants essentially two directions. So the first one we want to do is the turret forward direction. The second one we want to do is the direction from the turret to the player, and that we can get just straight up from our local position, since our local position is also the direction. So we can just take the player pause relative to turret, and that should give us an angle. So in our finite state machine, which we can pull up here, we wanted to save this value out because we're going to use this for transitions. So we'll go ahead and write that out, and that's going to be animator.setFloat. An animator, by the way, is passed to us as part of this state machine behavior, so we don't have to look it up. And the name is, I believe it's angle to player degrees. Double check on that real quick. Angle to player degrees, yep. And the value is going to be our angle. Awesome. And now we got to turn to face the player. Although, first of all, let's just double check and see what we're doing here. So we're going to be updating our angle in that property, I'm sorry, in that parameter. And if we take our animator window and we dock this over to the side, and we go ahead and play our game, then we'll be able to see that value hopefully being updated. So if I hit play, I can use my left and right arrow keys to move my player. And when my player becomes visible, apparently in my script I called this can see player and not can we see player. So just go ahead and update that real quick. Alright, let's try that again. So when can see player is true, we transition over to this state, and our angle to our player, that looks like a pretty good number. It's going between 12 and 20 degrees. Here's an issue though. This is giving us, say, 16 degrees, but if I go to the other side, it also gives us, say, 16 degrees. So it's giving us an angle between, but it's not giving us a direction. We don't know if we need to turn left or turn right to face the player. So unfortunately, it looks like this vector3.angle isn't going to work because it's giving us a non-directional angle. It's just giving us the angle between and not whether the angle is left or right. So the easiest way probably to do this is just to use the mathf trigonometric functions. So we're going to do a bit of trigonometry to figure this out. So we're going to say our angle is equal to mathf, and we're going to use the atan 2. So this is the arctangent, and basically we can give it a x and a y, and it'll tell us the angle. So in this case, our player position relative to turret.x is going to be our x, and this is part of the reason why we brought this all into local space. This is the local x from our turret. And then we're going to pass in the player position relative to turret, and in this case it's actually the z rather than the y, since we're along the flat world plane. And this is going to return us, all the trig functions return us things in radians. We need to transfer this to degrees because we have said our angle is going to be in degrees. So we then need to multiply by rad to degrees. And if we save that, and if we head back over to Unity, go ahead and hit play, then as we move to the left we see, excellent. This is negative around 9 or 10 degrees. Notice we've transitioned to this attacking player state, which is why this is no longer updating. and this is positive 10 degrees and negative, give or take, 10 degrees. Now, by the way, the reason that we've transitioned over to this is we actually have a bit of a logic error in our conditions, because negative 10 is less than 5. So really what we want here, we want to add another condition. We want the angle to player degrees to be less than 5 and greater than negative 5, since now we have a direction to our angle. And if we go ahead and do this again, then we see that our script and our state machine are all working correctly. So we're about 15 minutes in. We'll cut this video in half. We'll take a break here. But just kind of as a quick summary of what we did, is we started out with two very basic scripts. Our player basically has a movement script that moves them back and forth and provides a singleton. And our turret has a script that looks for the player, and it tells our state machine whether or not we can see the player. And it also provides a singleton, and that's basically all it does. So the vast majority of our logic is going to take place inside this state machine. And we did set up our state machine. We assigned it to the animator on the turret gun. We set up our various states. We set up the conditions and the transitions between those states. And then we started to define some logic. And in the next video, we're going to actually start turning our turret to face the player, and then we're going to look at attacking the player, firing bullets at the player, and then we're going to do a couple of tweaks to make this a little bit better.